Alright, I'm doing this screencast hopefully to help out with motion maps. Let's go ahead and get started. Motion maps, let's go through the concept of a motion map. Motion map is a lot like a strobe light picture. What you do is you see an object when the strobe light is on, and then the strobe light goes off and you don't see the object and it does something, maybe moves, and then the light comes on again and you see it in a new position. Very similar to these pictures that I've posted here. So we've got a spot here where the light is on, and then in here the object's moving but the light's off. Then we take another snapshot, the light comes on and we get to see the object again, and then the light goes off and we don't see it, and on and off, and we get this picture that looks like this. That is essentially a motion map. So what I'm going to do is I'm going to label this up with some times. Very important to know, the time frame of what you're doing for a motion map. Typically what we're going to do is we're going to call each time frame a second. It's usually the easiest, unless it's somehow some other way indicated that that's not the time frame. Usually a 1 second interval is a really easy interval to use, and it's not going to affect anything. The very first thing you want to identify is your 0. So this is at time 0. So that would mean that this would be 1 second, 2 seconds, 3 seconds, 4 seconds. So when the time is started, the object's here, and then 1 second later we see the object here, a second later we see the object here, another second later here, and so on. This is essentially a motion map. It's a plot of position. Essentially what this is, a motion map could be considered a one-dimensional position time graph. So a motion map is a one-dimensional position time graph. Now for this particular motion map, we can see that these time frames, these positions for these time frames are evenly spaced, which would indicate that this object is moving at a constant velocity. And really, for the time being, until we get into the next unit, that's what we're going to consider. We're going to consider things moving at a constant velocity. So constant velocity is indicated by even spacing. Now, just to contrast that, again, we're not going to get into this until the next unit, but to contrast this, this is a similar stroboscopic, I'll go with stroboscopic, photograph of a falling object. Well, we all know what happens when an object falls. It picks up speed, gets faster and faster, and we can see that up here is time 0. When the object is released, and then we've got at 1 second, 2 seconds, 3 seconds, 4 seconds, 5. Let me do that a little better here. 5 seconds. 5 seconds. There we go. 6 seconds, 7 seconds, 8 seconds. Now we've got these lines in the background to give us some reference points, and as we can see, this is not evenly spaced. We start here, and then our first picture is right here, and then here, and here, and here, and here. We can see these spaces getting wider and wider because while this thing picks up speed, it's not a constant velocity. This is actually accelerating. Again, for the time being, we're going to stick with stuff that's simple, moving at a constant velocity. Let's go ahead and make a simple motion map. We'll go ahead and get some simple data here. Say we've got an object. We'll go look at time and position. Again, it's really a one-dimensional map, one-dimensional graph. Let me show you what I mean by that. 0, 1, whoops, 0, 0. So at 0 seconds, it's at position 0. 1, it's 1 unit later. 2 time units, it's at 2. 3, it's at 3. 4, it's at 4. And we're gonna. It doesn't matter what time units we're using or what position units we're using. It could be seconds in meters or seconds in centimeters. This is just a general example. So what we've got is we've got our motion map, which is essentially a number line. And we pick our 0, and then 1, 2, 3, 4. And what we want to do is we want to make sure these marks are evenly spaced out. This is essentially our number line, just like a graph. We're not going to number them. We can just count them out for ourselves. And what we want to do is at 0, we're at position 0. So I'm going to go ahead and put my first position there. And I'm going to label this right away. Time equals 0. At 1 second, I'm at 1 unit. At 2 seconds, I'm at 2 units. At 3 seconds, I'm at 3 units. At 4 seconds, I'm at 4 units, and that's all the data we have. So these dots represent position. There are 3 things that can be represented by on a motion map: position, velocity, and acceleration. Well, again, we're not going to get to acceleration yet. That's next unit. We're just talking about something with constant velocity, which is no acceleration. It's not speeding up or slowing down. So what we want to do is we also want to indicate velocity. And velocities are indicated by an arrow. The arrowhead itself gives us direction. And then the length is the speed. Now keep in mind, velocity is a vector, and it's a combination of direction and speed. So direction, if we just take away direction from velocity, we get speed. That's basically the number. In this case, it's the length of the arrow. So with this particular motion map, I know that it's from time 0 to time of 1 second. It's headed in this direction, so that's the direction I'm going to put as my arrowhead, and I can make my velocity vector any length I want, as long as for this constant velocity I make them all the same size. So I've got an arrowhead that represents the direction that the object's headed, the direction of the velocity, and then the length of that arrow represents the speed. So these are all the same length, indicating that it's all the same speed. And I'm going to go ahead and finish up labeling this for the times, and that's at 4 seconds. It's not necessarily required that you label the times. I like doing that just so that I know what's happening at each time interval. But what I highly recommend is at least identifying your time 0 so that you don't mess that up. Typically, one of the more common mistakes is to the very first mark you call 1. Well, it's the first one, so it must be 1. First one's always 0. Keep that in mind.